Solving this equation. So we have an exponential equation, right? So on the left-hand side, we have 9 to the power of 8n plus 6. On the right-hand side, which is equal to, is 27 to the power of n squared minus 1, multiplied by 3 to the power of 1 minus 3n. So looking at this, first thing that comes to mind is they're all different bases. So the base is the number downstairs in the exponent, right? So the 9, 27, and 3. But I know that these three numbers are all multiples of 3. So what we can do is change their base into a common base, right? So we want to change 9 into 3, right? Base 3. 27 into base 3, and 3, well, that's already done for us. So let's do that. So 9 we can write as 3 squared. So instead of 9, I'll put 3 squared. Everything else stays the same though. We have 8n plus 6. So I've just replaced 9 with 9. But instead of writing it as 9, I've written it with base 3. So 3 squared. Likewise, 27 is 3 to the power of 3. Right, so I'm just replacing 27 with 27, but it's expressed in base 3, and it's still n squared minus 1. We still have multiplied by 3 to the power of 1 minus 3n. Awesome. So now we can use some power rules. So on the left-hand side, we have 3 to the power of 2 to the power of 8n plus 6. So powers of powers we multiply. So that becomes 3 to the power of 2 times 8n plus 6, right? Just to group them like that. Similarly, we have 3 to the power of 3 times n squared minus 1. I'm just using brackets here to make it clear that the 3 is times n squared, and it's times by minus 1. And then our 3 to the power of 1 minus 3n stays the same. What we can do, we could expand the brackets. Let's do that. So 3 to the power of 16n plus 12. And then 3 to the power of 3n squared minus 3 times 3 to the power of 1 minus 3n. Awesome. We can now use another power rule. When we multiply exponents with the same base, we add the powers. So maybe more familiar to you is x squared times x cubed. That becomes x to the power of 2 plus 3. In this scenario, instead of x as our base, we have 3, and instead of to the power of 2 or 3, we have these expressions, but exactly the same thing. So that becomes 3 to the power of the first power, 3n squared minus 3, and we add to that the second power, 1 minus 3n. Right, so when we multiply exponents of the same base, we add the powers. Now we can simplify that a little bit further. Right, we have 3n squared, we have a minus 3n, we have the minus 3 plus 1, that becomes minus 2. Right, so I just grouped the like terms in this one. Alright, now, awesome, so we're here. We have the same base. So what we can do is jump to this line here. So that's 16n plus 12 equals 3n squared minus 3n minus 2. So because our exponents had the same base, we're able to equate their powers. So there's a bit of behind the scenes work going on where we're taking the logs of both sides and we're using a log law, but jumping to this step is totally fine. And now we have a bit of a quadratic, right? We have a 3n squared term. So now we're just solving a quadratic. So I'll take these terms to the right hand side. So we'll minus 16n, so that becomes minus 19n, and we'll minus 12, so that becomes minus 14. That's all equals 0. So we have a quadratic equation which we can solve. Since I'm a bit lazy, I will use my calculator, but you can also solve this by the quadratic formula or factorizing by grouping. Equation, polynomial, degree 2, a is 3, b is negative 19, c is negative 14. F1 to solve. So x is 7, or negative 2/3, or n is 7, or n is negative 2/3. So we've solved the equation all the way back up there. I know, it's a lot of work, so let's summarize this one. We started with an exponential equation, and the bases of the exponentials terms were different. However, they had a common base of 3. So we were able to change the bases to 3. We then used power rules like powers of powers, and when we multiply powers, we add the exponents to simplify it to this. Since they are the same base on both sides, we were able to equate the powers, right, like so, which gave us a quadratic formula. Ooh, come on. Work. Plus 12, which gave us a quadratic formula right here. Well, quadratic equation, excuse me, which we then, in my case, I used my graphics calculator to solve. In your case, you should try factorize by grouping or the quadratic formula.